In this video, we're going to do a multi-point analysis for benzoic acid. We know what that structure is, and it's used as a calibration standard for melting point apparatuses, and so it has a melting point or freezing point of about 121 degrees Celsius, depending on the literature reference you use. Here on the bottle it says 120.9 degrees Celsius to 123.2 degrees Celsius. Now, melting point is always a range. So what we have up here on the top is a view down the melting point apparatus, and we'll adjust the lighting here a little bit so that it's ideal. And we'll auto focus this here on the tube. All right, so right now at this temperature, this substance is a solid, and I'm going to go ahead and measure the melting point of this by increasing the temperature here on the control valve. And ideally you want to raise the temperature so that the heater warms up about a degree, maybe 2 degrees a minute, very maximum. Okay, so 1 to 2 degrees per minute increase in temperature is a good setting there. Okay, so what we'll do is we'll adjust the knob here just a tad. Okay, the temperature should start rising. Okay, we have a slowly increasing rate of temperature, and what I like to do is turn this tube around just by spinning it to take a look at things. Okay, right now it's completely solid. It looks like a waxy, white solid material in there, and it's not yet melting, which is good. This substance is fairly pure here that I have in this test tube, in this microcapillary melting point tube. Okay, so what you want to look for is a wetting of the sides, or a somewhat change to liquid. Okay. Now, if you look at this, there seems to be a morphological change here. You can see how the sides are becoming clumped. It seems to be wetting the sides of the tube, particularly on the right there. And so this is when we would say that it's beginning to melt, 120.2 degrees Celsius. Okay, it's continuing to melt and fuse. We call this fusion, right? When solid particles melt and become one in a liquid phase. And it's still opaque, well, translucent. Light does not pass through this sample yet. So we keep doing this, we keep waiting until it looks completely homogeneous. That is to say, light passes completely through the material. Okay? And like I said, I like to turn the tube a little bit so that I could see the point at which that happens. Okay? Sometimes I tap it as well. You saw me do that earlier. So it's becoming more and more homogeneous there, and it's hard to tell now if that's uniform. So I might tentatively write 122.7 degrees Celsius for the final temperature there, okay? So I think it's 122.7. So that's how you do a melting point range. You want to record the initial temperature and the final temperature, okay? And now that's fully homogeneous, okay? So that's the correct way to observe and record your temperatures.